What about volume? Volume is section 24.2 in the textbook. We're covering essentially 24.1 and 24.2 here. Not absolutely everything in both of them. But as with area, we can step things up from, I mentioned this before, but from a line, which is in one dimension, to a square, which is in two dimensions, to, let's see if I can do this. Not quite, but close. To a cube, which is in three dimensions. That's not quite right, but you get the idea. So in this one, we're only measuring the distance back and forth. In this one, we're measuring the area. But in this one, we're measuring all of the space contained inside the cube, what we call the volume. So let's go back and think about how this will affect the units involved. I'm going to do, in fact, a different example from the one here because I want to start with something a little simpler. I'll go ahead and do it here. What if, I have a cube. I'm not going to be as careful about drawing it as I was before, where each side is 1 meter. Just take my word for it. This is a cube. May not look like it. And so I know that this, the volume, is 1 cubic meter. What if I wanted that volume in centimeters? And actually, there's a reason why centimeters are often really nice. We'll talk about that in a minute. Well, this same cube, if I labeled it in centimeters, this would be 100 centimeters, 100 centimeters, and make sure I get all the 3 different dimensions, 100 centimeters. So the volume of this would be 100 centimeters cubed. Which works out to 1 million cubic centimeters. So 1 meter was 100 centimeters. 1 square meter was 10,000 square centimeters. Notice that there's 2 zeros here. 1, 2, 1, 2, 3, 4. And 1 cubic meter is 1 million cubic centimeters. And now I have 2 more zeros again, 6 zeros. All right, let's go back here. We need to check with our metric chart in this case. So we have decameters and we have centimeters. So let me write down the relevant facts here. So this is not decimeters, which is a tenth of a meter, 10 centimeters. It is a decameter, which is 10 meters. So we have decameters and we have centimeters. And 1 meter is 100 centimeters. So I am going to use my factor label method just because that's how I like to do it, to convert decameters to centimeters. So 1, not decameters cubed yet, just decameters. 1 decameter, I'm going to multiply this by 10 meters over 1 decameter. So my decameters cancel. And I'm going to multiply this, because now I have meters on the top that I want to cancel, by 100 centimeters over 1 meter. And I end up with 1,000 centimeters, which makes sense. There's 100 centimeters in a meter, and then 10 of those gives me 1,000 centimeters. So 1 decameter is 1,000 centimeters, which means 1 cubic decameter is 1,000 centimeters cubed. In other words, 1,000 centimeters times 1,000 centimeters times 1,000 centimeters. Well, 1,000 times 1,000 times 1,000 is 1 billion cubic centimeters. Or you could write 1 times 10 to the 9th cubic centimeters. And now, 15.7 decameters. We can do the factor label method. We can just exchange decameters cubed, for 1 billion cubic centimeters. I'm going to cross out cubic decameters and be left with 15.7 times 10 to the 9th cubic centimeters, or, to be in proper scientific notation, 1.57 times 10 to the 10th cubic centimeters. Now, suppose that I want to convert a different kind of measurement of volume. It's still a metric. It's still in the metric system, but milliliters here. There's a very convenient fact that has to do with how the metric system is defined, which is that 1 milliliter is the same thing as 1 cubic centimeter. 1 milliliter is a measurement of volume, and it's actually the volume 1 cubic centimeter. And we can go even further for water and say that this weighs 1 gram. And that's, there are some specifics around that, like it's at 4 degrees Celsius and 1 atmosphere of pressure, I believe, because the density of water changes slightly depending on the temperature and the pressure. But in general, 1 cubic centimeter of water, also 1 milliliter of water, weighs exactly 1 gram. So let's use that to finish this question. I have 475 milliliters, and I want that in a measurement of cubic meters. Well, first, I'm going to convert it to cubic centimeters, and that's just a 1-to-1 conversion. 475 milliliters is 475 cubic centimeters. 1 cubic centimeter we need to figure out in terms of meters. So I could go back and look at that, but I don't want you to memorize things. I want you to be able to figure them out as we go. So we'll do the same thing here. 1 meter is 100 centimeters. So 1 cubic meter is 100 centimeters cubed, which is 1 million cubic centimeters. Flipping this the other way, 1 cubic centimeter is 1 times 10 to the negative 6 cubic meters. So I can simply write this as 475 times this. I'm going to replace with the equivalent value here, times 10 to the negative 6 cubic meters. There's Joy. I'll introduce you to Joy in a moment. And so I can evaluate this in scientific notation pretty easily. 475 times 10 to the negative 6 is, well, I can write that first part as 4.75 times 10 to the 2, and I still have times 10 to the negative 6, and this is meters cubed. So this is 4.75 times 10 to the negative 4 cubic meters. There's one more intended as group, but separate exercise for you to do, and I will post the answers included in the notes that I put up later. That's the end of this section for chapter 24. It is also the end of what I am teaching you in this course. So if you've stuck around this long, I really want to say thank you. I will post a separate thank you. I so much appreciate all of your patience in this time that we've been going through, and I really hope that all of you stay happy and healthy and everything else. And please, if you're at the university next year, and I'm at the university next year, because who knows, I'm not full-time faculty and things are tenuous right now, please drop by and say hi. I would love to see you. Thank you.